Welcome back, guys. We are still continuing on collections framework, and today we are going to look at the following three content. So collection utility. This is a utility class, and the name is collections. As we know that collection is an interface that inherits, or you can say implements, iterable. So collections, it's a utility class. So this class consists exclusively of static methods that operate on or return collections. It contains polymorphic algorithms that operate on collections, contains wrappers which return a new collection backed by a specified collection, and a few other odds and ends. So these methods of this class all throw null pointer exception if the collections or objects provided to them are null. So we can review this method quickly, this class quickly. We say it's called collections. So you can see this is a class. It contains a whole lot of things in here. So the definition I read to you guys comes from the Java doc. So always read the documentation for you to be able to understand. So we see that it has a private constructor which actually prevents anyone from creating its object. So all the static methods are here. We see the sort that is overloaded, binary search, and many other methods. So you can go through this collections utility and see what you can be able to find. So it's very useful when you want to perform like a couple of things in your application, sorting, searching, and all that. Then we have other utility methods that were added in Java 9. So from Java 9, this method was added. So if I can just go into list class, so this method of as you can see since Java 9, and it's overloaded method. Yeah, so we also have okay, sorry, I shouldn't have closed that. We also have another method that was added in Java 10. It's here since Java 10, copy of sorry, as we see here. So it is advisable to also read about this method. They are very useful. Time won't allow me to explain everything. Just read about what this method can do. You can pause the video and just read the Java doc. Trust me, you will need to use this method in your application. Then we have comparable. This interface imposes a total ordering on the objects of each class that implements it. This ordering is referred to as the class natural ordering, and the class compared to method is referred to as its natural comparison method. We also have another interface called comparator. Then a comparator function actually imposes a total ordering on some collection of objects. Comparators can be passed to sort method, such as collections.sort or arrays.sort, to allow precise control over the sort order. Comparators can also be used to control the order of a certain data structure, such as sorted sets or sorted maps, or to provide an ordering for collections of objects that don't have a natural ordering. It is generally a good idea for comparators to also implement serializable, as they may be used as ordering methods in a serializable data structures like TreeSet, TreeMap, And in order for the data structure to serialize successfully, the comparator, if provided, must implement serializable. And it has the compare methods as we saw. That takes 2 arguments. So we can just look at these 2 quickly. So the question could be, when do you use one over the other? So when you want to provide natural ordering for your object, let's say you have employee object as we had here. So I'm just gonna stop this. Let's say we have employee object. I'm just gonna come here, and this age, you can just remove all this and say this is ID, private string name. Then we have the constructor there for you. Sorry, we want to create all the getters and setters. Okay, I want to create the getters and setters for both. Then we have okay, so we have the equals and the hash code, which is fine. So now you want to order these elements based on we can say based on ID. So, and you want to provide a natural order. So what you could do, you could say implement comparable. Then what are you ordering? Employee. Then you have to implement the compare to method. So in here, what you want to do is you want to compare the ID of the object passed to you with this object, with this ID. So you can say this dot ID. Okay, let's do this. Let's say integer dot value of ID. Then we say dot compare to o dot ID. So when you have done this, you have actually implemented the comparable interface, and it's going to compare your employees based on the ID. So if I was to come here, just to show you quickly what I mean by this, just gonna go to list. So what I'm going to do here, I'm going to have list. Okay, let me say I'm going to have a set, and this set would be set of employees so we can say employees equals to new TreeSet. This is fine. So what we want to do is employees dot add new employee, let's say 4 comma Java 1. Here we can say 1. Okay, here you can say Java 4. Java 4. You can say 3. Java 3. So we have this list. So what we want to do is we want to iterate through this list. So what I can do, I can say list iterator of employee equals to iterator employees dot list iterator. Okay, maybe what we can say, we can just say iterate. So let's just remove this list iterator for now. So we have this and we want to iterate. So over while dot has next and say system.out.print iterator.next is an employee dot get name. So let's run this code. For now I can just comment this code so that it doesn't disturb us. Or what I can do is I can say copy, duplicate this to make it list 3. And list 3 sorry, okay, it's fine. Let me just leave this one the way it is. So what I'm gonna do here is I am going to delete everything here. I'm gonna be left with what I want to test. Let's observe the result of this code. Right, sorry. So what I'm going to do now, I will need to do this so that this code works. Affected the previous code. Let's run now. This should be fine. See, we have Java 1, Java 3, Java 4. See that it has ordered this list for us. And how does it know? It knows because of the implementation of this method that we are having here. It's actually comparing the values that we have. We can compare by anything. We can even compare by history. So what we can do, we can say name dot compare to all dot name. This will still give us the same output, as you can see. So this is what comparable help us to achieve. But now let's say you want to order list. Let's say you don't have something like this. You have, let's say maybe you have a list, and we know that ArrayList does not maintain ordering for you. So I'm just going to do this quickly. Let me give this a correct name. So what I'm going to do, I'm going to take this and copy it and make it demo 4. So what I will do here, I want to have list of strings, and what I'm going to do is I'm going to say arrays dot this list, then we have Java 4, we have Java 1, we have Java 3, and if we run this code say list, let's see what we get. We see Java 4, Java 1, Java. So we want to order these things and they are not ordered. So what we can do here is we can provide a comparator here for this, because now we want to order some objects. We don't this is not a natural ordering. You can think of a comparator as an ordering that you can provide at runtime, not a natural ordering. So now we want to order this thing. So what we could do, we could provide a class here. Could say public static class, let's say my ordering implements comparator, and those things that we want to order, they are strings. So we have to override that method compare to. So here what we do, we just say o1.compare to o2. That's it, we are done. So what we can do now is we can say collections. Remember the collections we talked about in the previous in our lecture. We want to use it to sort. What are we sorting? We are sorting our list. And what is our comparator? New my ordering. And then we run list. So I want us to run this list before ordering and after ordering, and then we see what we'll get. You see, this was before ordering and this is after ordering. Before ordering and after ordering. So let's just say we don't pass it our own custom comparator. You see, it still works. And why does it work? Let's review why it works. Go to int string. You see, it works because string implements comparable. So it knows how to compare strings. So let's see the compare to method in here. How does it work? Compare to, as you can see, compare to, okay, let me say compare to, this is the compare to method. So it knows how to compare two strings. So that's why it's working. If you put a list of objects that are not comparable, you are going to have issues. So for instance, if we have this, say string here, and then we remove this, already we see we are having issues because list demo is not comparable. You can't compare it. That's the problem that we were highlighting. Other than that, we don't have anything. So the interview question could say, when can you use which? So just know that you use comparable for natural ordering, and you use comparator when you want to order some ordering of some objects, maybe at runtime or at any point in time, which is separate from the natural ordering.